Hi, welcome to the Excel for Statistics class. This course teaches you statistical thinking concepts that are essential for learning from data and for making business decisions. By the end of the course, I hope you will be able to perform basic statistic analysis using Microsoft Excel. In this meeting, we will learn some statistical functions that can be used in Microsoft Excel. Functions are predefined formulas that perform calculations by using specific values, called arguments or structure. Functions can be used to perform simple or complex calculations. The actual functions that we will learn in this meeting are, so we have 10 functions to learn in this meeting. So the first one is var S, and then the second one is var A, and the third one is var P, and then number 4 is var PA, and then for the number 5 is covariance P, and then number six covariance S, and then number 7 is permute, and then number 8 is permutation A, and then number 9 is confidence norm, and then number 10 is mode single. Okay, so we can break this 10 function into 4 type of function. So for the var S until the covariance S is the variance type function. And then for the permute and permutation A is the permutations type function. And then for the confidence norm is confidence intervals type function. And then for the mode single, it's the average type of function. Okay, without waiting for, we just go to the first function. The first one is variance S or variance. Variance S is the function used to calculate variance based on one sample. Okay, so it's used to calculate variance based on one sample. The syntax of the function is equal for S, and then the item is number 1, number 2, and so on. So for the number is arguments from 1 to 255 relating to the population sample. Okay. So we have this data set for variance as how to learn to perform the variance as. So you may type this data set first before we continue to perform the variance as function. So you may pause this video, and after you finish this data set, you can play this video again. Okay, so I assume you already finished your data set. So we have data from 2402 until 2488. Okay, to perform the variance as function is pretty simple. Equal, you just type equal var.f, then to the range from beginning until the last one. So this is the result for the variance as perform result, and then the result is 1853.1667. So this is the result from the variance as function. Okay, so variance as function is used to calculate variance based on one sample. Okay, and then For the next one is variance A or var A. Variance A or var A is function used to calculate variance based on a sample include numbers, text, and logical values. The syntax of the function is equal var A, variance A, and then the item is value 1, value 2, and so on. So for the value is the arguments 1 to 255 relating to the one population sample. So for the the data set is the same as the variance S. Okay, so you may just copy the data set to the new sheet, and then let's perform the variance A function. Okay, to perform the variance A function is almost the same with variance S function. So var A, and then to the range from this one, and here's the result. The result for the variance A function is 1853.1667. Okay, and then the next one is variance P. For P. Okay, variance P is function used to calculate variance based on the entire population. The syntax of the function is equal variance P, number 1, number 2, and so on. So for number is arguments 1 to 255 relating to the population sample. So the dataset is the same like the previous variance function. So you may copy this dataset into the new sheet, and then let's perform the variance P function. Okay, so for the variance P function, we type equal for the P, and then just do the range. Okay, so the result for variance P is 1667.85. So this is the result for the variance P function. And then for the variance, the next variance function is variance PA. Okay, so for the variance PA function is a function used to calculate variance values based on the entire population, including numbers, text, and logical values. The syntax of the function is equal variance PA. The item is value 1, value 2, and so on. For the value is the arguments 1 to 255 relating to the one population sample. Then for the variance PA function, to perform this kind of function, we just type equal for PA, then do the range from the beginning until the last one. And the result is 1667.85. So these are the results for the variance function. And then we will learn about the covariance function. So covariance P function is a function used to determine population's covariance. The mean product deviation for each pair of data points in two data sets. The syntax of the function is equal covariance.p, array1, array2, and so on. So array1 is the first range of integers, and then the array2 is the second range of integers. To perform this covariance.p, you must type the dataset first. So you may pause this video and type the dataset. If you already finished this dataset, you may continue the video. Okay, so I assume you already finished the dataset. So let us perform this covariance P function. Okay, to perform the covariance P function, we type the equal covariance P, open the bracket, and then put the array for the array 1, we put the array from 16 until 9, and then put the semicolon symbol in here, and then put the array 2 from 10 until 10, and then close the bracket and enter. So the result for the covariance P is 4.16. Okay, so this is the result for the covariance P function. And then we will learn how to do the covariance as function. So covariance as function is a function to determine the sample covariance, the average product of the deviation for each pair or data into datasets. The syntax of the covariance as function is equal covariance, and there are two items in there, array 1, array 2, and so on. For the array 1 is the first range of integers, and for the array 2 is the second range of integers. So we have this data set that are same like before. So you maybe just copy this dataset from the covariance P dataset before and put it in the new sheet. And then let us perform the covariance as function. So to perform the covariance as function, we put equal sign here, and then covariance as bracket. And then for the array one, we put from the 16 until 9, and then put the semicolon symbol in there, and then put the array 2 from 10 until 10 in here. Okay, just close the bracket. And the result is 4.62222 and so on. So here there's the difference maybe between the covariance P and then the covariance as result. Okay, so the covariance P is used to determine population covariance, the mean product deviation for each pair of data points into data set, and then for the covariance S is the average product of the deviation. Okay, so that's the difference between covariance P and then the covariance S. And then we will learn about the permute function. Okay, so permute is coming from the permutation. Okay, so the permute is the function used to find the number of permutation for a certain number of objects that can be selected from the number of objects. So the permutation is a way, especially one or several possible variations in which a set of number of things can be ordered on arrays. Okay, so the syntax of the function is equal permute. The item is number and number chosen. For the number is an integer that describes the number of objects. And then for the number chosen is an integer that describes the number of objects in each permutation. Okay, so you may make this kind of table first before we continue to perform the permutation function. So you may pause the video first, and after you finish this kind of table, you can play this video again. Okay, so I assume you already finished the table, and then for the number, let us put for the number we put 4 in here for the example, and then for the number chosen maybe we put 2 in here just for the example. And then how to perform the permutation function is we type equal permute, open the bracket, put the number in here, and then for the number chosen put the 2 in here, and then close the bracket. Okay, so the number of permutation for number 2 is number 4. 44 is 12. Okay, so here is the permutation for the number the number 4. Okay, so maybe you want to change it to 6. Okay, so for the permutation for 6 is 30. Okay, so we go to the next function, permutation A. So permutation A is a function used to find the number of permutation for a number of objects with loops that can be selected from the total object. Okay, so it's a bit different with the permutation that we already learned before. So it's to find the number of permutation for a number of objects with loops. Okay, the syntax of the function is equal permutation A, and then the item is number chosen. For the number is an integer that describes the number of objects, same like the permutation before. And then for number chosen is an integer that describes the number of objects in each permutation. Okay, so we may use the table from the permutation before and just put it in the new sheet. Okay, for the number, maybe we just put 4 in here. And then for the number chosen, we put 2 in here. And then let's try to perform the permutation A function. To perform the permutation A function, we type equal permutation A, open the bracket, put the number, and then put the number chosen in here, and the result is 16. How about we change the number into 6? The result is 36. Yeah, it's a bit different with the permutation, the original permutation before. When we put 6 in here, the permutation is 30. And then when we put number 6 in the permutation A, and then the number chosen is 2, the result of permutation A is shown as 36. Okay, and then the next function is confidence normal. The function used to determine the confidence interval for the population mean using a normal distribution. Okay, the syntax of this function is equal confidence norm. The item is alpha, standard deviation, and size. Alpha is the level of significance used to calculate the level of confidence. And the standard deviation is the population standard deviation for this data range is assumed to be known. And then the size is the sample size. Okay, so we have the new table. You may make the table first before we continue to perform the confidence normal function. You may pause the video. After you finish the table, you can play this video again. Okay, so I assume you already finished the table. So maybe we put, for the alpha, we put 0.01, just for the example. And then for the standard deviation, we put 1.5. And then for the size, we put 10. This is just the example. You may change the number. Okay, so to perform the confidence norm, we put equal confidence norm. Okay, the first one we put alpha, second one we put the standard deviation, and then the last one we put size. And then the result is 1.221823. 1, 2. Okay, 1.2, around 1.2. So the result is 1.2 for the confidence norm for this kind of data set. And then the last one, we will learn about the mode single function. Okay, the mode single function is this function that is used to find out the most frequently repeat or repetitive values in an array or range of data. The syntax of function is equal mode single. The item is number 1, number 2. The number is the arguments 1 to 255 for which you want to calculate the mode. Okay, so we have the new dataset for this mode single. You may type this dataset first, and after you finish the data, you may pause the video first, and then after you finish the dataset, you may play the video again. Okay, so I assume you already finished the dataset. So we have 7, 4, 7, 9, 5, 4.8, 1, 4, 7, 3. Okay, to perform the mode single, we put equal mode dot sngl, and then the 7 until the 3, and the result is 7. Okay, so for the mode single is the most frequently repeated values. Okay, so as you can see here, 7 appears 3 times. Okay, number 7 appears 3 times in this dataset. So it is the most frequently repeated value in the data column in here. Okay, so I think that's all for this meeting. So I hope you already learned a lot about the variance function, and then for the permutation, the confidence, and then the mode function. So I hope it's gonna be okay. So I hope it will help you in your journey to learn the statistics for Excel for statistics. So see you again in the next meeting. Goodbye.